In this presentation, we'll just go over the 6th set of truth tree problems. So as I've done in previous lectures, now I'm going to move a little bit quicker. Still try to give you the info that I think is relevant, but make sure that I don't have you needlessly watching the screen. If you're like, I've heard this 1,000 times, I don't need to hear it some more, just give me the answers. So, start with this premise here. Main operator is going to be the double arrow. So double arrow. On the left-hand side, we're going to branch out, and then they're going to match. So either they're both true, or they're both false. Then we just got to flip the tilde Q's across like this. So that is the first premise. Looking at the second premise, it's just a tilde Q, so we're going to flip it across, bring it down here. Oops, sorry, should recognize that at the beginning. Q. So these red Q's are coming from this tilde premise. Next, we just gotta do our conclusion, because our second premise is done. Conclusion here is a wedge on the right hand side. Wedges on the right hand side stack like this. And now we're done with that one. And so just gotta go back through, look for counter examples. First one here, I see a P on the right hand side, P on the left hand side. So that'll close off. I've got a Q and a Q, so that one will close off. So since they both close off, we've got a valid sequence, and since it's valid, we don't have to provide a counterexample. Moving on to the second one, try to stay consistent with the colors. Got P arrow, Q or S, S or Q, arrow M, go my line, not M, arrow, not S. So starting with this one, main operator is our arrow, so our arrow will branch out. S. Then we just need to break down our wedge on the left hand side here. So wedge on the left hand side would break down to left hand side on the left hand side, right hand side on the left hand side, like that. So now we've got that one taken care of. Main operator here in the second premise is going to be the arrow. We'll break it down in each of our branches down below. So left hand side goes on here. Same thing, I should go ahead and break these down too. So Q. And then M here, M here, M here. Then we've got to break down these wedges that are on the right hand side, which will stack again. Now we just need to break down our conclusion here. Main operator is the arrow. This tilde goes with this M. This tilde goes with this S. So breaking down an arrow, it's on the right hand side. We're just going to stack. And we're going to put not M on one side, not S on the other. Not M, not S. Not M, not S. Not M, not S. Not M. Sorry. Not M, not S. Not M, not S. Now we gotta flip those across, so my not M will go here. my not S will go on the other side, and then you just gotta repeat. M will go over here, S will go over here. M, S, M, come on, M, S, M, S, M, S. Alright. Now, we can finally go back through and check our branches to see if any of them close off. First one here, I've got an S on the left-hand side, S on the right-hand side, so that won't close off. I got an M and an M on this branch, so that one will close off. I've got an S and an S here, so that one will close off. I've got an M and an M here, so that one will close off. I've got an S and an S here, that one will close off. And then I've got an M and an M here, so that one will close off. So since they all close off, it's got to be valid. And since it's valid, we don't need a counterexample. So that is problem 2. Now we're on to problem 3. P and QoS. Q, it's not P. So main operator here, and this one is the tilde, so we just gotta flip it across the way. And QoS. Now we've got a ampersand as the main operator here, so ampersand on the right hand side, put both on the right hand side. Then we just got to break down this wedge here, so we'll stack it like that. And now, so we're good here. And then I've got this tilde P that needs flipped across. P will go here, P will go here. So those are coming from the conclusion here, like that. So now we just gotta look back through, see if we got any contradictions. First one's staring right at us. We got the P on both sides. And here we've got a Q on the right and a Q on the left. So going back up through this whole branch, we got the Q here, Q here. So that closes off. As they both close off, we got a valid sequence. Since we got a valid sequence, no counterexample needed. So on to problem 4. Got P arrow, not P and S. S, not P. So looking at our first premise up here, main operator is the arrow, so break it apart using our arrow rule on the left hand side. That. Then we'll flip this ampersand across to get rid of the tilde. And then to use our ampersand rule on the right hand side, we'll branch apart, put each side on the right hand side, and that is our first premise broken down way. Second premise is just a single letter, so don't have to do anything there. Now we just need to flip the conclusion across. So E, E, E. So all those are coming from this tilde up here. Now, broken everything down. So let's go back through. Here we got a contradiction, obviously looking right at us. Got another one that's looking right at us. Now, let's go back up through here, and I do have S on the right hand side, S on the left hand side, so that will close off. And so since it all closes off, this will be valid, and there won't be a counterexample for it. So on to the fifth one, we've got two premises. We've got not P and Q, then we've got not P or T, and our conclusion is just T by itself. So first premise is a tilde, because it is operating on both of those together. That's why we get the parentheses, so we'll flip it across. Q. Then we need to branch out. EQ. Like that. Then this one's done. Now we need to do this one. Our main operator is our wedge. So we'll break it apart. That. Wedges each side goes on the left hand side like that. Then we just need to flip these two tilde P's across. And now go back through, look for contradictions. So here I don't see one, because I got a P on the right, P on the right, T on the right. None of those will close off. So that one is open. Let me put Q. Here I got a T and a T, so that will close off. Here I've got don't have anything, so that one's gonna open. And this one I got the same T as before. It's two T's. So I've got two different open branches. I've got to go back through my sequence, and I've got three different letters. I've got P, Q, and T. Sorry, it's invalid. I got an open branch. Then my counterexample. Now we can use either of these open branches. If you use this first one right here, you see you got P on the right hand side, so that's false, and you got T on the right hand side, that's also false. But then you don't see Q, and if you remember, whenever you're in this instance, you can write either true or you can write false, because what it's saying is that Q has no bearing on whether or not this is valid. P and T by themselves say that it's not going to be valid based on those values. So you can write whatever you want in here. If you rather, you could look at this one, because you do have a Q and it's saying, oh, it's false. But really, what this side here is telling you is Q doesn't matter. As long as P is false and T is false, it's going to be invalid. So you can put either one, but you have to put a specific value. You can't just put T or F, or you can't just put P and T by themselves. You have to give a value for Q. You have to give a value for each of the letters that appear in the sequence. So, but this one is invalid, and then we've got our counterexample there. We got two premises here. We've got P or Q arrow S. Then we've got not P and not Q, or sorry, not S. And we got our conclusion, which is not Q, like that. Main operator here is our wedge. So left hand side here, the right hand side here. Then break down this arrow, Q, S. So now our first premise is done. Let's look at our second premise. Second premise, our main operator is the ampersand. So that's going to be a stack, because it's on the left hand side. So we have not P, not S, not P, not S, not P, not S. Then we just gotta flip those across. P, S, P, S, P, S. So that one's all done. Then we just need to flip our conclusion across our line, so Q, Q, Q. And since I usually do this, I'll do it again. So those Q's are coming from our conclusion, getting flipped across the tree to get rid of the tilde. So that's everything we needed for that one. Now we can go back through. First one, I see those two P's will cancel out. Here I see the two Q's will cancel out. Here I see the two S's will cancel out. So all the branches terminate. Since all the branches terminate, this is valid. And since it's valid, we don't need a counterexample. Now on to 7. Got not P and Q S, and not P and not S. So not Q. So start with the first premise. Main operator there is a tilde because it's operating on all of this. So we'll flip it across the way. P and Q and S, like that. Now we've got an ampersand on the right hand side. So branch it off. P will go here, Q and S will go here. Now I've still got this ampersand here that's on the right hand side. Q, S. So all of this was this premise. Now let's move on to the second premise. Second premise, main operator is the ampersand. We got tildes attached here and tildes attached here. So ampersand on the left hand side says we stack. Not P, not S. P, not S. P, not S. So then we gotta flip those across, get rid of the tildes. Now we've broken down that one as far as it will go. And then we gotta flip the not Q across like so. And we can look for contradictions. So going back up through this first one here, I don't see one. I've got Q, S, P, P, all of them on different sides, so that one's open. Let's look through here. I see I got a Q here and a Q here, so that one's closed. Then I've got, let's see, through here, I don't see one. I got Q, S, P, S, so that one's also open. So since we have at least one open branch, it's invalid. So we need a counterexample. All of our letters are P, Q, S. I'm going to look at this first open branch, and I see that I've got a Q on the left-hand side telling me it's true, S on the right-hand side telling me it's false, P on the right-hand side telling me it's false. Could have used this one just as well, and looks like I would have got the same exact values there too. But either one you could have used for your counterexample. Remember, you only need one counterexample for invalid. You don't need multiple ones or all of them. You just need a single one. So this will work out for us. And so that is problem 7. Now on to 8, we have P arrow Q or S, Q arrow P, and we've got P double arrow S or Q. Then main operator here is the arrow. So we'll put the left hand side here, we'll put the right hand side here, like that. Then we've got wedge here. So QS. That'll get rid of that premise. So now we've got arrow here. So arrow says branch out. I've got a Q on the left, right, Q, Q, E. So that one's broken down as far as it will go. Now I just have my conclusion. Main operator here is the double arrow. Double arrow that's false is also a branch. It says not going to have very much room, so I'm going to do that. Alright, so double arrow that is false says that I have to make it so they don't match. So Q, D. Just gonna copy everything that I just did on that one branch to all these other branches. Oops. Those shouldn't all be red. My apologies. Those should be there. And then we'll need to Q, Q. Have these on the right hand side here. Q, Q. Q. Now this is getting a little fuzzy. Q. Then we just need to break down all of those wedges. So wedge on the right hand side, stack, so I'm going to do all of these at once. S or Q, 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 S or Q. And then all of these will branch. Luckily, I don't think I give you one that's this involved on the exam. S or Q, S or Q. I erase that P or else it's gonna look confusing. S or Q, S, Q, S or Q, S or Q. So now we need to go back through and see if we've got any contradictions. Here in this first one, we've got a P on the left-hand side, P on the right-hand side. We've got in the second one, S, Q, P. Doesn't look like we've got anything here. Here we've got Q, Q. So that one will cancel out. I might erase these circles just real quick. Now looking at this one, I got P on the left, P on the right. That one cancel out. I've got PP. So those will cancel out here and here. Next, I've got let's see, Q and a Q. Those will cancel out. And I've got a Q and a Q up that way, so I know these two will cancel out. Then I've got Q, S, P, P, Q. Got a Q on the right, Q on the left. Next Next one I've got P on the right, P on the left. So I got those two Q's there and there, so I know those two will cancel out. Next one I see I've got S and an S. Then I've got, let's see, SPQS. Looks like that one is also, that one looks open. Got QQ closed. Then QSPPS. I've got S and an S, so that one will be closed. And I've got E and a P. So those will close. So I'm going to double check, make sure I didn't miss anything. SPQP. Nope, that one's open. SPQS. And that one's open. So those two are open. So since I have at least one open one, it's going to be invalid. So I'm going to need a counterexample. I have P, Q, and S as letters here. So I'm going to look at this one here. So S is on the left-hand side, so that makes it true. P is on the right-hand side, that makes it false. Q is on the right-hand side, that makes it false. So this one's very branchy, as you can tell. I don't think I give you one on the exam that is quite this bad. So if this one is a little bit harder to follow, just know that it was doing the same stuff multiple times over. All these branches down below are the same exact branch, just there's, what, three terminating branches in each quadrant. So you got 3, 6, 9, 12, 15, 18 branches there, but they all pretty much look the exact same. But so this one's invalid because I've got this counterexample, got these two open branches, one here and one here. So again, enough to be invalid. All right, on to problem 9. We've got not P and not Q and P arrow S, and conclusion is a not S. So main operator here in the first one is ampersand, because these two tildes are going with the single letter. So but not P, not Q. We'll flip those across. E, Q. Now we've got an arrow here for our second premise. So take the left-hand side, right-hand side here, take the right-hand side, put on the left-hand side here. So that one's done. And then we've got our inclusion, which is a tilde that needs to be flipped across on both of those. So now we want to go back through, see if there's any counterexamples, or see if there's any things that, any branches that close off. Here, I don't see anything. I got S on the left, P on the right, Q on the right, P on the right again, and then S on the left, Q on the right, P on the right. So nothing there. So they are both open, which makes it invalid. So since it's invalid, we need a counterexample. We need each of our letters, which are P, Q, and S. I'm just going to look at this one right here. S is on the left-hand side, so that's true. P is on the right-hand side, so that's false. Q is on the left or on the right-hand side, also making it false. So there's our counterexample, and it's invalid. Now from 10, got P and Q S arrow M. And we've got not Q arrow P and M. So this premise might look a little daunting only because there's so much stuff going on. But remember, we have parentheses that are saying all of this and this. So that's just telling us do our ampersand rule first. So we'll just take P, and then we'll take all of that, put it here. Now we've just got this side and this side, so we're going to use our wedge rule. Branch out. Q here, S arrow M here. So now we just need to break down this arrow. So S here, M here. So now we finally broke down our premise all the way. So all of this was this premise, but you see we just did it one step at a time. We did our ampersand rule here, then we did our wedge rule here, then we did our arrow rule here. So just one thing at a time. When you're doing anything in logic, really, just know it's one step at a time. So now we just got to do our conclusion. Main operator here is our arrow. Make this. So arrow will go on the left hand side. Then our right hand side will go on the right hand side. That. Now I'm just gonna go ahead and flip this not Q across real quick. So a Q, 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 and then we've got our ampersand here on the right hand side. Sorry about that. So now P M P E M. It's all coming from that ampersand right here. So now everything's broken down with that one. So let's go back through, check for contradictions. Here I see I've got a Q and a Q. It's good enough to close off this one and this one. Now I'm looking at this third branch from the left. I see a P, Q, S, another P. So I actually do have a P all the way up here. So remember, you gotta follow all the way up. So that one closes off. Now I've got an M, Q, S, P. That one is open. Nothing closes off there. This next one is going to close off with this P. That one is good because that one's going to do the same thing as the previous one where, let's see, let's use orange. So we gotta go all the way up. You see we'll get this P here, this P here. Now this last one, we have two M's that will cancel out. An M here, M here. So those will cancel like that. And that just means that we have to back through. We've got one open branch. One open branch is enough to make it invalid. It's invalid. We got to provide a counterexample. We got to provide each of our letters. We have P, Q, S, and M. And we want to look at our open branch. So our M is on the right hand side. So that means it's false. Our Q is on the right hand side. That's false. Our S is on the right hand side. That's false. And our P is on the left hand side. That's true. So again, to build this counterexample, you have to use the values that are in the branch that's open. You want to follow this branch all the way up and use whatever values you find for them. M, Q, S, and P. So that is problem 10.